Hello friends, welcome to session 6 on projection of plane surfaces where we have been doing top view starting problems. Now we'll start with another problem. A pentagonal lamina of size 25 has a corner on HP. I told you for pentagonal lamina, okay, you can make edge on HP or corner on HP by one single position of the pentagonal lamina drawn. Okay, and rotate it about this corner till the surface of the lamina is inclined at 60 degrees to HP and the edge opposite to the corner is lying on VP. Draw projections. Okay, now you see here. Now draw 25 pentagon as usual. Okay, and in the previous problem also it was there. Corner on HP, surface inclined at 60 degrees to HP. This was there already. Okay, now in this problem what they've said is, see here, corner HP, surface inclined at 60 degree, you got the top view. Okay, first stage front view was median length, and since it is moved parallel to VP, this length and this length are same. Okay, take 60 degree, get the top view. When you get the top view, all edges would have lost true length except AB. AB is still in true length because AB is parallel to HP. That is why true length is seen in the top view. In fact, you can see in this way also. This is 25. Now here everything is in true length. No, this is 25. Same 25 is seen here. Okay. Now corner on HP, surface inclined at 60 degrees to HP. Okay. What they've said is edge opposite to the corner is lying in VP. Now corner is this, corner on HP is D. Edge opposite to the corner is AB. That is lying in VP means put AB on X line. Put AB on X line. That means this, move and copy, paste and rotate in such a way that AB lies on X line. Once you do this, take the projectors up. Okay, projectors up. On this you should get AB, on this you should get CE, on this you should get D. In that way you get the projections are. That means you should understand that in this position it is corner on HP, surface inclined at 60 degrees to HP. Okay, keeping 60 degrees to HP constant, about corner D, I'll rotate the lamina. I'll rotate this lamina in any position. I can rotate it to any position. As long as 60 degree is constant, the top view does not change. What I have done is, I have rotated in such a way that I have put AB on XY line. That means in this way, in this position, the problem becomes corner is on HP, opposite edge is lying in VP with surface inclined at 60 degrees to HP. When you are looking from the front, how the front view appears, I have written here. Top view has already been done. Okay. In that way, a complex problem has been made a simple here. Okay. That means a pentagonal lamina of size 25, corner on HP, surface inclined or median inclined at 60 degrees to HP, and edge opposite to the corner on HP is lying on VP. That is the, for this position, you have to draw projections, you have drawn it. Okay, now you see here, there is another problem. A pentagonal lamina of size 25 has a corner on HP, same as that, and rotated about this corner till the median containing this corner is inclined at 30 degrees to HP, and the top view of the median is inclined at 30 degrees to VP also. Draw projections. See here, same way you do. Okay, now as you see here, draw 25 pentagon. Same thing, AB 25. This is 25 plus 18. ABC 25 minus 18. CD, okay. CD 25 plus 54. ED 25 minus 54. In that way, you can complete this. B dash, A dash, C is seen, E is not seen, C dash, E dash, and D dash. Okay, edge on HP means B dash, A dash you would have made on XY line. Since corner is on HP, you have made D dash on XY line. That is why for pentagonal lamina, from one single position like this, you can either make B dash A dash lie on XY line or D dash lie on XY line. If B dash A dash lies on XY line, it will be edge on HP. If D dash lies on XY line, it is corner on HP. Okay, now it is corner on HP. Okay, with median inclined at 30 degrees to HP. Okay, median or surface inclined at 30 degrees to HP. See here, this is the median, correct now? This is dx is the median, and since this is parallel to VP, what we are seeing in the front view is median length only. Since this entire thing is rotated, about the corner D parallel to VP, okay, this length will remain same. That means first edge front view and second edge front view will remain same. That means it is as good as telling surface inclined at 30 degrees to HP is same as median dx d dash x dash inclined at 30 degrees to HP. Okay, in that way I got the top view. Okay, now what they have said is the median is inclined at 30 degrees to HP. Now in this position, if you observe, all have lost true length except AB. Okay, AB 25 means 25 only. Okay, what you have done, you see here. Dx I have inclined at 30 degrees to VP. That means top view the median. This is Dx. Please observe this Dx. Here it is true length. It is median is like a line inclined at 30 degrees to HP. When it is 30 degrees to HP, the line what you get here in the top view is not true length. It is reduced. That is why what I'll say is top view of the median is dx. No, it is not true length of the median. It is the top view of the median. That is the median which is inclined at 30 degrees to HP. This is the top view of the median. The top view of the median is inclined at 30 degrees to VP. Okay. When the top view of the median is inclined at 30 degrees to VP, that is move and copy, paste and rotate it in such a way that dx is inclined at 30 degrees to VP. Okay. Then you take the projectors up, okay, and get the points and join the boundary. Okay. This is how it is seen in the front view. The problem is, I'll repeat, a pentagonal lamina of size 25 has a corner on HP with a median inclined at 30 degrees to HP. That median is dx. Median inclined at 30 degrees to HP. Now, I have rotated about D, this top, this lamina, I have rotated with respect to corner D, okay, keeping this inclination of 30 degree constant, such that dx is inclined at 30 degrees to VP. The top of the median inclined at 30 degrees to VP. That means in this change of position method, the problem becomes complex. That means it lands up in a complex position for which you are expected to write front view and top view. Top view has already been done. The front view is written this way. As I said just now, take the projectors and join the outer boundary. Okay. This is how this problem, a good problem, has been done. Okay. Now you see here. Now you go for hexagonal lamina. Hexagonal lamina, I am telling you, you see here, XY, VP, HP, vertical plane, horizontal plane. See here for hexagonal lamina, I am repeating again and again. Hexagonal lamina, edge position is different, corner position is different. That means if they say hexagonal lamina has an edge on HP, you have to take one position. If they say hexagonal lamina has a corner on HP, means you have to take another position. Now it is hexagonal lamina edge position. Please remember hexagonal lamina edge position. And observer position is always in this way, perpendicular to HP for top view, perpendicular to VP for front view. Now see here, A, B, C, D, E, F, 6 edges. When you are looking from here, B is nearer, A is away, B dash, A dash, C is nearer, F is away, C dash, F dash, D is nearer, E is away, D dash, E dash. And if you rotate it, if you lift this up, it will be resting on edge AB, B dash, A dash on HP, surface inclined at 30 degrees. Even if you lift B dash, A dash, it will still be resting on edge on HP only, that is D dash, E dash will be on XY line. That means whether you lift this edge up or this edge up, okay, it will be edge only on HP. That means you can't make corner on HP in this position. That means for hexagonal lamina, when they say edge on HP, you have to take to this position only with one of the edges perpendicular to XY line. Okay, this is the concept. Okay, hexagonal lamina edge position is this, not corner. It is edge position. Okay, now you see here. Hexagonal lamina of size 25 has an edge on HP. You take edge position and rotated about this edge till the surface of the lamina is inclined at 60 degrees to HP and the edge on HP is inclined at 30 degrees to VP. Okay, it's a simple problem. Here, draw an hexagon. Compulsory edge position means one of the edges should be perpendicular to XY line. Okay, AB you write 25. This is 25 plus 30, 25 minus 30. This is 25 plus 30. This is 25 minus 30. And then you can join this. And one demo will be there later on. You will know how to do and all that. Okay. But anyway, this hexagonal lamina you draw. This is B dash A dash, C dash F dash, D dash E dash. Now you know it is clearly edge position. Whether you lift it up here or lift up here, it is edge only on HP. Now the problem says it is edge on HP with surface inclined at 60 degrees to HP. Okay. Since it is moved parallel to VP, since this is lamina is being moved parallel to VP, okay, this front view and this front view will remain same. Okay, it is resting on edge AB. B dash A dash is on HP. Surface inclined at 60 degrees to HP. Okay, get the top view. Okay, get the top view. A, B, C, D, E, F. In that way, get the top view. Now, you should know at this stage, what are the out of 6 edges which have maintained true length. As you know here, this is 25 means AB, since it is in HP, AB anyway has to be in true length. Since DE is parallel to HP, this is also true length. All other edges AF, EF, BC and CD, since they are inclined, they have all lost true length. Okay. Now you see here. Now what I do know is edge on HP, surface inclined at 60 degrees to HP. I don't change the inclination to HP. Now I can rotate the hexagonal lamina about AB, but I'll maintain 60-degree constant. I'll not change the 60-degree constant. As a result, top view remains same. Okay, the second stage top view and third stage top view should remain same because inclination to HP remains same. Okay, now you see here. What I have done is edge on HP is AB. That is inclined at how much to VP? 30 degrees to VP. Okay, edge on HP is inclined at 30 degrees to VP. Take the same top view, that is move and copy, paste and rotate it in such a way that it is inclined at 30 degrees to VP. Okay, this and this are same. Then now the problem is what? It is this position. As soon as you look at this, you should know it is edge AB on HP, surface inclined at 60 degrees to HP, edge on HP is inclined at 30 degrees to VP. Okay, for this position the top view has been written. For this complex position, when you look from the front, how it appears in the front view has to be drawn. Okay, that is why you take the projectors up and take the points from here A, B, C, F and D, A. In that way, you are able to get the projections for this position. Okay, for this position. That means hexagonal lamina of size 25 has an edge on HP with surface inclined at 60 degrees to HP and edge on HP is inclined at 30 degrees to VP. Okay, and you have drawn projections for this. You see that you draw XY line, you draw VP, HP and all that. Okay, and you know very well first stage front view is same as second stage front view because this lamina, when the true length of the media, that is hexagonal lamina, is moved parallel to VP, the front view won't change. That is first stage front view and second stage front view will be same. In the same way, second stage top view and third stage top view will be same. I have told you the reasons and all that. Okay, this comes to the, we'll come to the end of session 6. Thank you for watching. Thank you.